Hey, Willkommen and welcome to the fifth lecture in the Design of Embedded and Intelligent Systems course. Today, we're looking at implementation and specifically hardware. So, what do you need to build a robot's hardware? Well, if we look at this toy drone, this is a Rise Tello, then we can see it's got a computer inside of it, an Intel NVIDIA Smira 2 VPU. It's got some sensors, so you can see there's a camera over here. It's got a rangefinder, barometer. You can see it has some actuators. So it's got 4 motors, which will spin these propellers. You can guess that it's got some electrical components in here. You can see this battery peeking out to power up everything. And of course, it has also hardware. It has this shell protecting it, these propellers and such. So in this course, we usually use an Arduino to control robots' motors and talk with analog sensors. We use a Raspberry Pi for mid-level processing, and we use various other computing devices like desktops and laptops to do even more processing. Here are a few questions about sensors. If you want, please try to pause your video now. I'll give you a little time to do that. Okay, I assume you've paused your video and tried to answer these questions. Let's go for it. What sensor can a robot use to sense its pose? One sensor a robot could use is an accelerometer measuring pitch, yaw, and roll. How does an accelerometer do this? It's measuring the acceleration of gravity. What does a gyrosensor measure? Angular velocity. What does a Hall effect sensor measure? Magnetic field. In this course, you also have some Hall effect sensors, and you use that to measure how many times the robot spins its wheels. Here are some more sensors. Do you know the names of all of these? Again, I'll give you a little time to pause your video if you want. Okay, let's go for this. So we have a sonar sensor, a camera, an infrared range sensor, a brightness sensor, a force-sensitive resistor, and a passive infrared range sensor. At the bottom, we've got a LiDAR, we've got a wind sensor, an anemometer, we've got a sound sensor, a microphone, we've got a gas sensor, and we've got an IMU, inertial measurement unit. Okay, let's look at some actuators. Do you recognize these actuators? Please give it a try. And when you're ready, let's go on. Okay, on the left, we have a DC motor. This spins very, very fast, so we might want to lower the speed and increase the torque, and that's what we get when we attach a gearbox, and then we have a gear motor. But we might also want to know the position of the lead of the motor, and then we can use a potentiometer for that, and that's often used in servos. If we don't really care where the motor lead is, but we just want it to go in precise steps, we can use a stepper motor. These are common in disk drives or 3D printers, when it's okay if somebody maybe stops them. Solenoids are a kind of linear actuator, so there's quite a few different types of actuators we have. Let's try another quiz about actuators. Please give these questions a try if you want, and then we'll go on when you're ready. Okay, let's go and try to answer these. Is a differential drive robot holonomic? So first, a differential drive robot can be like the robots we have in this course, which have 2 motors, each one drives a wheel. And that is not holonomic. So if you've studied this before, holonomic in this case means that the degrees of freedom of the robot equal the total degrees of freedom in the environment. So if we're looking at a robot that's moving around in 2D, then a differential drive robot can't go to any orientation and position directly. It has to maybe back up and move around. This is the same thing for a car-like robot. If you have a robot with omnidirectional wheels, however, it is holonomic. Okay, what kind of maps might be generated by active SLAM? Well, what is active SLAM? First of all, what is SLAM? SLAM is simultaneous localization and mapping. Active SLAM is when a robot tries to maximize the gain to the accuracy of its map by picking where to go. And different kinds of maps can be used for SLAM, any kind of SLAM. For example, topological maps, which are like graphs where you have vertices and edges, or grids. Name the problem. Given the joint angles for a robotic arm, where is the end effector? This is kinematics. The opposite problem is inverse kinematics, where we want to know the angles to reach a certain position. And remember that there can be multiple solutions for that. Okay, we go on to electronics. So once we have the brains of the robot and we have various sensors and actuators, we might have to have some supplementary circuitry to get that to work well. So again, please try to say the names of these components, and you have a bit of time to pause. Let's go on. So on the left, we have a resistor, then we have a capacitor, we have an inductor or coil, we have a transistor, we have a diode and an LED on top, a light emitting diode, and we have on the right some kind of IC. Okay, let's go on to look at circuit diagrams and symbols for electronic components as well. Because it's also really nice to be able to read circuit diagrams. So again, you can try to answer these, try to see if you know the names for these things. Okay, let's go on. On the left, we have a resistor, then we have a capacitor, we have a diode, we have a switch, a transistor. This triangle here is depicting Ohm's law, which is really useful, I think, for simple electronic stuff. So the voltage is equal to the current times the resistance. We have a voltage divider circuit. This can be really useful if you're using something like that sensor you just saw, that force sensitive resistor, which has a varying resistance. Then you can swap that in place of R1, and then you know if somebody is pressing your sensor or not when you read in between R1 and R2 with an analog pin of a microcontroller. These things are useful for various reasons. So you can drop voltage if you want to a level that you can read easily, or you can also make voltage dividers with capacitors and other components. On the right, we have a very simple LED circuit. If you want to attach an LED to your robots in the course, like as brake lights or something, then you can use something like that. Buses. Okay, so you probably want to connect various sensors to your robot over a bus. So there's many different types of buses. Here are some examples of some serial buses. On the left, we have a TDL serial UART. It's transistor logic. We have I2C or I2C, as you like. We have an SPI, then on the right. So how do we choose one of these to use with our robots? Well, the UART is quite nice if you just want to connect two things together. It's quite simple. Just remember to always connect Rx on one side to Tx on the other side. That's the only thing to really be careful about, I think. And then baud rate as well. Make sure it's the same baud rate. I2C is useful if you want to have a bunch of different sensors on your bus, but it's not maybe so computationally intensive. SPI requires more lines, but you can do stuff with more intense computation like displays. Okay, let's look at some hardware connectors now. Now that you've got your circuits set up, then you have to mount it somewhere. You have to make sure that it's not flopping everywhere like crazy. So I'll give you a little bit of time if you want to try to see if you can name these hardware connectors. Let's go for it. So on the left, we have some JST connectors. The thing on the left is, if you're a hobbyist, you might know this is a Beck connector, otherwise RCY. And then afterwards, something like a pH. I'm not sure exactly which. There's really lots of types of JST. Middle is a Dean's connector. So these are useful when you have a bit more current flowing, and you do with your robots. You have a really big lithium polymer battery, so you want something nice like that. Molex connectors are quite common. We have them on our turtle bots here, for example. At the bottom, we have a screw with usually screws are pointy at the bottom, bolts are not, but of course that's just a simplification. Standoffs or spacers, you can do that to get your electronics sort of off the ground a little bit so that it doesn't get short-circuited or whatever. Nuts to tighten bolts. You have washers to distribute pressure so you don't rip a hole in something. And lock washers will make sure it's quite tight. So here, like this split washer here. Thanks for listening. See you next time. Hope you learned something interesting.